You sit down to work. You have a clear task and a deadline, but within minutes, your phone buzzes. You glance at it just for a second, and 20 minutes later, you're deep in an algorithmic scroll, completely detached from what you were trying to do. You are not alone in this experience. Dr. Gloria Mark at the University of California, Irvine has spent nearly 2 decades tracking human attention spans on screens. This chart shows the collapse her team documented. In 2004, the average time people spent focused on a single screen was 2.5 minutes. By today, that number has dropped to just 47 seconds, a 97% decrease in sustained focus. You might have heard the claim that human attention spans are now shorter than a goldfish's. That is a myth, derived from flawed survey data. Our baseline brain capacity isn't shrinking. What is failing is our specific capacity for sustained attention. This distraction stems from a systemic biological hijack engineered by the attention economy, a predictable outcome of the environment we inhabit, rather than a failure of individual willpower. Let's slow down the timeline to see how this works, starting at second 0. When your phone rings, it triggers an involuntary reaction called the orienting response. This is an ancient neural mechanism that evolved to help us detect immediate physical threats, but it gets triggered just as effectively by a notification chime. By second 2, you check the screen. Whether it's a message or a news alert, your brain releases a microdose of dopamine. This neurotransmitter acts as a learning signal, reinforcing the exact behavior that led to the reward. As you slide into an infinite scroll, you enter a variable reward loop. Every swipe delivers a tiny, effortless dopamine hit. Over time, your dopamine receptors become desensitized, a process known as downregulation. Your brain now requires increasingly more stimulation just to achieve a baseline sense of satisfaction. This exact psychological principle makes gambling addictive. You never know when the next pull of the lever will deliver something highly entertaining. Psychologist B.F. Skinner originally identified this mechanism, known as a variable ratio reinforcement schedule, discovering that unpredictable rewards produce the most compulsive and persistent behaviors. Your neural circuitry is being chemically trained to expect constant, high-reward, low-effort stimuli. The platforms are actively altering how you seek satisfaction. Now we hit minute 2. You put the phone down and try to resume your work, while keeping a fraction of your attention on the digital distraction you just left. This diagram illustrates what happens instead. Your brain is rapidly toggling between 2 distinct systems: the default mode network, which handles mind-wandering, and the executive control network, which manages goal-directed focus. Every toggle between these networks extracts a switch cost. Your brain needs time to disengage from one set of rules and load another. This leaves behind attention residue, where thoughts about the previous distraction linger and actively pollute your ability to focus on the current task. By minute 3, you are feeling the friction. Clinical research shows that after a single interruption, it takes an average of 23 minutes and 15 seconds to fully recover deep focus. This constant cycle of starting and stopping causes ego depletion in the prefrontal cortex, the part of your brain responsible for executive attention. It fatigues like an overused muscle, a condition exacerbated by the cortisol released during chronic modern stress. The true cost of a 1-second glance is the rapid, structural exhaustion of the brain region required to do meaningful work. Fortunately, the brain's capacity for neuroplasticity means the same mechanisms that eroded your focus can be utilized to rebuild it. Your neural pathways adapt to how they are used. The first step to recovery is resetting your dopamine baseline. A 24 to 72-hour digital detox, eliminating non-essential screen time completely, helps restore your dopamine receptor sensitivity. Next, you have to control your physical space. A study from the University of Texas demonstrated that simply having a powered-off phone visible on your desk measurably drains your cognitive capacity, because part of your brain is actively suppressing the urge to check it. With a clear environment, you can apply Cal Newport's framework of deep work. Structure this work using the Pomodoro technique, 25-minute sprints of absolute focus, followed by a short break. This aligns with your brain's natural rhythms, allowing you to stop and recover before the vigilance decrement sets in. Environmental design serves as a mandatory biological shield for the recovering prefrontal cortex, protecting it from competing stimuli. To actively strengthen that executive control, Neuroscientist Andrew Huberman highlights a specific 17-minute interoception meditation practice. Focusing internally on your breath and bodily sensations has been proven to reduce attentional blinks, the tiny lapses in focus that break your concentration. But none of these strategies will work without optimizing your sleep. This requires eliminating screen time at least 60 minutes before bed, because the blue light emitted by devices suppresses the melatonin production needed for restorative rest. The medical literature is clear. Without adequate sleep, the prefrontal cortex cannot repair its executive focus capabilities. You cannot outwork or overcaffeinate a sleep deficit. Reclaiming your attention requires transitioning from passive digital consumption to proactive, intentional system design. Start today. Disable all non-essential push notifications on your phone right now. Then let me know in the comments below. What is the longest uninterrupted deep work session you've managed to pull off? If you found the science in this video helpful, hit subscribe to keep rebuilding your cognitive capacity.